Okay, we're going to work on z-score today. So what z-score is the following. So the other day, or earlier today, depending on when you watched the last video, we looked at standard deviation and connecting it with percentages, which is good. Let's say we have a standard deviation. What if we have this situation going on? X to the n bracket, let's go 100, comma, 5 squared. So that would mean 100 here, 105, 110, 115, 95, 90, that's a horrible 90, and 85. Okay? And then we also knew the percentages. 64, 64, 13.5, 2.5, 0.15, 13.5, 2.5, and 0.15. So we knew those percentages. So we could tell you, if I asked what percentage of the people are between 90 and 100, a score of 90 and 100, and you would just go, okay, that makes sense. 64 plus 13.5, which would equal 77.5%, right? Oh, 90 and 100, shoot. I'll make that 105, so my math makes sense. 90 and 105. What did I do there? Jeez Louise. That's 34, that's 34. Now my math is all wrong. Let's go back. I got 68 and 34 mixed up in my head. I was thinking 68, and I wrote down 30. Yes. So let's go between 100 again. This would be 34 plus 13.5, which would equal 47.5%. Would land between 90 and 100. And this is perfect for when we want answers that hit right on the dot here. Okay? So if they hit exactly on a standard deviation, it works perfect. And this is good for making estimates, right? Using standard deviation. But what would happen if I was looking for, let's say, a score of 92? Or a score of like 109? What percentages would I work from there? I can't use it because it doesn't land right on. And it's not exactly in the middle because there's more people in this half. I did 92.5. Because of the way it works, there's more people in this half than in this half of that section. So you can't really be exact. So that's where we use something called z-score. So if you're ever looking for an estimation using a value that's not an exact standard deviation, use z-score. Now, the z-score is the value minus the mean divided by standard deviation. So if I was to write this out, z is the value, so it's x, whatever x is going to be, minus the mean, divided by our standard deviation. Pretty sure I just did my standard deviation backwards. As such. Now, you may find other z-scores look like this. Oops. And they write mean with a fancy U. That's also standard deviation. So if you see that in any documents, then that's also mean. That also means these two things are the same. They're your mean. So, this is for finding the in-between points. Now, the one thing you'll need, is a z-score table. Now, I put a z-score table in your documents there. Let me think here. In D2L, in the table where it says that where you're watching this video, there's also a z-score table. Okay, the z-score table is going to look like this. Okay, it has all these numbers at the side. These are your z-scores down the side here. Okay, and then the percentages that apply to it are to the right. So if I was looking for, let's say, 1.4, negative 1.4. I would go to negative 1.4. Oh, negative 1.42. And then I go over to 0.2, and where these two meet, that's my percentage. Okay? So with that percentage, I'd have to times it by 100. So this is 0.0778 times by 100, which would give me 7.78%. Okay? And the important thing to know about a z-score, a z-score tells you the probability of what is below the number. Okay, so here is our normal curve, right, where we would have all these written and so on and so forth. Whatever the z-score is, we're looking below, always. So in that case, my 0.78, that would mean if I was drawing out my curve here, oops, there's my line here, which represents 7.78% below, which would also mean that in order to find it above, I would go 100 minus 7.78, which would be what? 92 point. So it's February. It's Family Day here, and we convinced my daughter that buses weren't canceled. Buses are canceled here in Guelph, but I convinced my daughter that buses weren't canceled, and I was going to let her skip school if she walked the dog. Now she's talking to a friend, so I may get busted. Okay, so you're always looking for below. Okay, so let's do some numbers here. Let's actually do above and below. So go below and above. So what percentile corresponds with a z-score of 1.5? So that'd be 1.50. So let's go to our z-score table. Now there's a negative side, and the negative side is from 50% below. It's going to be negative. And the positive is from 50% above. So if I'm looking for 1.50, I have 1.5 here, and I go over to 0. We're looking right there. 0.9332. 0.9332, which would mean 93.32%. That's the percent below. Now to get above, I could either go 1 minus 0.9332 or 100 minus 93.32. Okay, where's my calculator gone? There we go. That would mean 6.68% above. Right? So negative 0.88 now. I'll zoom in here. So negative 0.8 here. Then I'm going to go over. And there's where my two combine right here. 0.8194. 0.8194 or 81.94%. So above, I'm going to take 100 and minus off 81.94%, which is 18.06. Okay? So now I want you to, I'll give you a second, or pause the video here. I want you to do 0.45. Let's say you end up with a z-score of 0.45. What's the percent of it? 0.45. 0.45, so I'm up here. 0.4, 0.5. We're going to combine 67.36. 0.6736 or 67.36, that would be below. So we're doing our little curve here. It's that much below. But what's higher? If I'm looking for the higher part, it's 100 minus 67.36, which is 32.64. Okay. Now I could also go 1 minus 0.6736, which would equal 0.3264. Then I just have to times that by 100 to get that. Okay. And then lastly, let's try one more. Negative 2.30. So if you want to see if you can get it yourself, pause it. If not, negative 2.30. So I have 2.3 here, zeros right here. So 0.107. 0.107. 0.0107, I believe, if I'm not mistaken. So that is 1.07%. That would be below, and the above would be 98.93%. So in this case, let's say a z-score came out of the height of a person. That would mean this person is taller than 1% of the population and shorter than 98.93% of the population. Now, we could also look at what z-score corresponds to a percentage. So we're kind of going backwards here. So if I'm looking for a percentage of 70%, what z-score might correspond to that? I'm going to look in my chart here for 0. As close as I can get to 0.700. Now the odds that I get exactly are probably very low, but I can see if I can get as close as possible. So if I zoom in here, these are my two numbers that are closest to 0.700. And in fact, this number here is going to be my closer number. This is 0.015 off, that's 0.19 off. So the number that corresponds would be 0.52. 0.52 would be the z-score that ends up with an answer of 70%. Okay. So if we were doing 35%, now this is 35%, so I know it's going to be negatives since it's below 50%. So I'm looking for 0.35. I'll do some erasing here. So 0.35. I'm around here. Let's use what color. So 0.35. And between these two. Now, which one's closer to exactly 0.35? It is this one. Right? That's 0.02. Now, if I were to round that, 0.0020 off. Right? Where this one is 0.0017 off. So it's a little bit closer. So that is negative 0.39. Negative 0.39. Right? So let's do a couple more. I'll let you, if you want to pause the video, you can. Find 40%. 40% is going to be down here. Not 40. Let's get rid of this stuff. 40%, as close as I can get to 40%, is right here. So it's 0, negative 0.25. 0.0, oops, sorry. Negative 0.25 is my number. And lastly, 92%. So 92 is above 50, so it's going to be a positive number. And 92 on the dot, I'm looking right here, which would be 1.41. 1.41. So if you look here, I find as close to 92 as possible, which is 1.4. I go this way up to 1. Okay. I would suggest printing out this sheet if you can, or have it readily available either on your phone or tablet or something separate, so it's easy to see. All right, so let's do a couple questions with this. Now remember, our z-score formula is as follows. Z equals the x minus the mean divided by standard deviation. So suppose a population was normally distributed with a mean of 10. So I know my mean is 10. A standard deviation of 2. What proportion or percentage of the score are below 12.5? So my x is 12.5. So therefore I can calculate my z-score by, it'll be 12.5 minus 10 divided by 2. So 2.5 divided by 2 is, I have a z-score of 1.25. Now key here to look is asking for above or below. So it's asking for below, so we don't do anything to our number after we find it. So 1.25 is the number we're looking for. So I go to here, 1.2, I go over until I get to 5. So 0.8944. So I go to 1.2, and then I find my second decimal place here, 0.8944. So 0.8944, if I want it as a percentage, times by 100. So 89.44%. Okay. So, here we go. A patient was recently diagnosed with Alzheimer's disease, takes a cognitive abilities test, and scores a 45. So we know that my x is 45. The mean of the test is a 52, and standard deviation is a 5. What percentage of patients have his score and below? Okay. So we're looking for below, so we don't have to adjust anything. So our z-score is x minus the mean divided by standard deviation. So that is 45 minus 52 divided by 5. So I run that through my calculator. 42 minus, oops. Negative 1.4. That's why I got my calculator. I'm going to add the 0 in there so I know how far to go to my chart. Negative. So, go to my chart. Negative 1.4 is right here. 0 is right here. So I'm right there. 0.808 is my answer. So my answer here is 0.0808 or 8.08%. Okay, that's below. Now, if I was asked what percentage of patients in Alzheimer's disease score higher than that, I'd be 100 minus 8.08, which would equal what, 91.92% would be above. Okay. So, next one here. A fifth grader takes a standardized test, which has a mean. So there's our mean. Here's our standard deviation. And scores a 148. So that's our x. What percent of children are higher than 148? So we go to our z-score of z equals x minus the mean divided by standard deviation. Now feel free to pause it if you want to try it yourself before I get to the answer. So this is going to equal, my x is 148 minus 125 divided by 15. 148 minus 125. So I have 1.53 as my answer. Positive 1.53. So I go up here. .53, so I go to 1.5 over to 3, where those two meet up. 0.937. So 0.9370 times it by 100 gives me 93.7%. But that is below. So if I want above, I'm going to go 100 minus 93.7%, which I believe is 6.3%. I will double check it. Yep. So 6.3% of individuals have a higher mark than this child. Very good for this job. Right? So Pat and Chris both took spatial abilities tests with a mean. So the test has a mean of 80 and a standard deviation of 8. Pat scores a 76. Chris scores a 94. What percentage of individuals would score between them? Okay. So now we're looking for, if I draw a little chart out here, let's say Pat, I'm just going to make an estimation here. Let's say Pat scores here and Chris scores up here. We're looking for the space that's going to happen between these two. Okay? So what we have to do is we're going to find each of this, we're going to run this twice. And then we're going to minus the higher number from the lower number. It's going to give us our lower here. So for example, if let's say this was 30%. So that means there's 30% below. And let's say this one here was 70%. That would mean there's 70% below. We're trying to find the middle here, so we go 70 minus 30, which would just be erasing this end here, leaving us with the section we need. So we're trying to find out what's between them. Okay? So let's do Pat in purple. So Pat's z-score is x minus the mean divided by standard deviation, which is going to be 76 minus 80 divided by 8. 76 minus 80 divided by 8. Oops. That can't be right. 76 minus 80 equals, then divide by 8. Negative 0.5. So I'm going to go find his percentage right now. Negative 0.5. Negative 0.50, so we're right here. 30.85. Okay. Negative 0.5 and then 0, 30.85. So that equals 30.85%. Okay. So I'm going to read you my little chart here. Pretty good guess there. 30.85%. Now we're going to do this guy in blue, if I'm not mistaken. Let's do it in blue instead. So his Z score is going to be x minus the mean divided by standard deviation, which equals 94 minus 80 divided by 8, which is 1.75. So let's go find out what that is. So 1.7 is here, 5 is here, 95.99. 95.99%. So I was a little off on this one. 95.99. So if I want to find the middle of it, what's between them, I need to take the top one minus the small one, which will get rid of this bottom space. So 95.99 minus 30.85. 65.14% is between them. Okay, so this space here, 65.14% between. So 65% of the population is between those two test scores. Let's do one last one. So the mean weight of a baby being born is 9 pounds, and the standard deviation is 0.6 pounds. What percentage of babies are between 8 and 10 pounds? So we have to run this twice again. So we'll do 8 in purple. So Z is x minus the mean divided by standard deviation. So the x is 8. 8 minus 9 divided by 0.6. Negative 1.67 is my number. So negative 1.67. Negative 1.6 is right here. 7's way over here. 0.475. 0.0475 or 4.75%. I think that was my number, wasn't it? Yep. So there's my first number. Then my second one, 10 pounds. Z equals x minus the mean divided by standard deviation. So x is 10 minus 9 divided by 0.6. Oh, what do you know? So the exact same number but in the positive form. 1.67. Let me get rid of these ones. 1.6, and we're going to make our way over to 7. 95.25. 95.25%. The number was this. So to find the middle, right? So right now I have a situation where I have the purple right here, which is only covering 4.75% of it. And then I have this one way over here, which is covering 95.25% of it. So it's covering every. Sorry, this may be a little chopped up because the recording stopped right at the very end. I don't know exactly when. So this was my last part of it, where I had this curve where the first person was only above 4.75%. Second person was above 95.25%. So I got to find the difference between them, which would be this section right here between them. So we're at 95.25 minus 4.75, which equals 90.5% between them. Okay. Hopefully that's good, and we're good to go. Sorry, this may be a little chopped up because the recording stopped right at the very end. I don't know exactly when. So this was my last part of it, where I had this curve where the first person was only above 4.75%. Second person was above 95.25%. So I got to find the difference between them, which would be this section right here between them. So we're at 95.25 minus 4.75, which equals 90.5% between them. Okay. Hopefully that's good, and we're good to go.